Good morning. The hearing will come to order. Today's hearing is entitled Declining Polar Bears and Permafrost is a Global Warming Tipping Point Embedded in the Ice. This committee held 3 hearings on the 2007 report of the Intergovernmental Panel on Climate Change, IPCC, one of last week's winners of the Nobel Prize for Peace. For the working group on impact, adaptation, and vulnerability, stated that the rapid climate changes occurring in the Earth's polar regions would have cascading effects on key regional biophysical systems and cause global climatic feedbacks. The report described the polar regions as geopolitically and economically important and extremely vulnerable to current and projected climate change. And the report said the polar regions had the greatest potential to affect global climate change and thus human populations and biodiversity. In the past 12 months, there have been 2 remarkable stories related to the Arctic that suggest that those climate changes may be happening even faster than predicted and with significant negative consequences. Earlier this month, the National Snow and Ice Data Center at the University of Colorado reported that the Arctic sea ice cover in the summer of 2007 had fallen to its lowest point since 1979. Sea ice coverage was 39% below the long-term average for 1979 to 2000, and perhaps half the sea ice coverage of the 1950s. According to the Center, the Arctic sea ice has long been recognized as a sensitive climate indicator. When global temperatures rise, the sea ice cover sinks. And global temperatures in the Arctic have risen 4 degrees Fahrenheit since 1950. The lead scientists for the Snow and Ice Center warned that the sea ice cover is in a downward spiral and may have passed the point of no return. As the summers go by, we are losing more and more ice in the summer and growing less and less back in the winter. We may well see an ice-free Arctic Ocean in our lifetimes. The implications for global climate as well as Arctic animals and people are disturbing. There has not been an ice-free summer in the Arctic in a million years. Not surprisingly, the U.S. Geological Survey in September issued a report projecting that, based on the projected sea ice melts, 2/3 of the world's polar bears will be gone by 2050. The USGS study projects that in 3 of the 4 ice ecoregions of the Arctic, it is most likely that the bears will be extinct by 2010. In the 4th region, the modeling projects almost even odds that the bears will be somewhere between having a small population to being extinct, but a small population may not be enough to sustain the species. Polar bears are adapted to hunting from sea ice. They hunt primarily ringed seals and, to a lesser degree, bearded seals. Less sea ice means less habitat. The USGS analysis relied on models to project polar bear populations that are more conservative about the melting of sea ice than the steeper decline that is now being observed in the Arctic. Polar bears are adapted to hunting from sea ice. Diminishing bears and sea ice are only the most widely reported aspects of a warming Arctic. Global climate scientists worry about tipping points, atmospheric processes that could lead to a rapid and irreversible change in the overall global climate or sea level rise. The Arctic contains several potential sources for a tipping point in the boreal forest, the albedo effect of melting ice, and one of the most frightening, carbon and methane release from melting permafrost. Again, the polar regions, the Arctic and the Antarctic, have the greatest potential of any region to affect global climate everywhere. The impacts of global warming will be greater in the polar regions, and those impacts will also produce feedback effects that have globally significant consequences. First, ice and snow reflect solar radiation in a process known as albedo. It helps the Arctic keep the Arctic cool and the Earth cooler. When there is less ice and less snow, the exposed soil and water absorb solar radiation instead of reflecting it, and more solar radiation and warmth reaches land and stays in the atmosphere. It becomes a cycle. Ice melts and the snow ice and snow cover is reduced, resulting in less reflectivity and more warming, resulting in more ice melting and reduction of snow cover, and on and on. Second, because of higher temperatures in the Arctic, the permafrost beneath large sections of Europe, Russia, Alaska, and Canada is also beginning to melt. There are estimated to be almost 1,000 gigatons of carbon trapped in Arctic permafrost. A gigaton is 1 billion tons. Human use of fossil fuels currently emits approximately 7 gigatons of carbon annually. In 2005, scientists at the Snow and Ice Project projected 50% decrease of the topmost layer of permafrost by 2050, and as much as a 90% decrease by 2100. If that happens, the resulting release of CO2, carbon dioxide, and methane could have a warming effect on our climate that defies imagination. Another potential source for carbon release rests in the boreal forests of the north. Warmer weather has made them vulnerable to insect pests, and drought has resulted in the largest forest fire ever witnessed on Alaska's northern slope. It may also have damaged the permafrost. None of the models used in the IPCC's projections of the impact of global warming took into account the potential release of those gigatons of carbon. A vast area of the world that has been a net carbon sink could become a carbon dioxide and methane producer that would dwarf the production of carbon dioxide and methane now resulting from human activities. As Dr. Ted Schur wrote in Science magazine, factors inducing high-latitude climate warming should be mitigated to minimize the risk of a potentially large carbon release that would further increase global warming. Rapid Arctic ice and permafrost melt are the kinds of events with cascading effects that tip the planet's climate into an uncontrollable cycle of warming. The result could be an acceleration of the melting of the ice sheets in Greenland, inundating coastal communities, and devastating the world economy. For 20 years, we have heard warnings from scientists, first in a hearing held by Mr. Gore, an alumnus of this committee. Now we are seeing the consequences of global warming in the endangering of polar bears, in the eroding infrastructure of the Arctic, and in melting sea ice. Dr. James Hansen of NASA said a year ago that we have 10 years to act. If he is right, we now have 9 years left to put this country and the world on a path to reducing aggressively our carbon emissions. We certainly can do that, and probably at a relatively modest cost if we have the will. Some dismiss the threat of global warming as gloom and doom and proclaim themselves to be sunny optimists who believe things will turn out all right. Willfully ignoring dangers and turning a blind eye to all evidence that there is a problem that needs our urgent attention is not optimism, it is folly. It is optimism to believe that we will prove equal to the challenges before us, however daunting. And I am optimistic in that respect, but we better get about it. The chair now recognizes Mr. Sensenbrenner for an opening statement.
Thank you very much, Mr. Chairman. Today's hearing takes a wide breadth, from predicted declines in polar bear populations to whether polar bears should be listed under the Endangered Species Act, to melting permafrost and its implications, to the ecological effect of climate change on spruce tree populations. The individual topics are too complex to approach in depth in a single hearing, but the common thread is obviously climate change and the underlying truth that the Arctic is melting. There is obvious value in bringing the world's attention to the problem, but we may have reached a tipping point when it comes to raising awareness on climate change. We have the world's attention. The question now is what we're going to do about it. As the diverse subject matter of today's hearing suggests, climate change can have broad effects that we are only beginning to understand. But as I have continuously maintained, solutions to climate change are no less complex than the consequences. Our approach to combating climate change cannot be short-sighted. We need to reduce our greenhouse emissions, but we cannot do so in a way that jeopardizes our ability to meet our energy demands or cripples our economy. Our energy demands are rising, and running out of conventional power plants is a real threat. We need to find solutions, like nuclear power, that limit carbon emissions, but also ensure that our energy needs will be met. We're also facing unprecedented economic challenges. As the challenges of competing in the global economy grow, rapidly developing countries like China and India have made it clear that they will not hinder their economic growth to curb climate change. I heard that repeatedly in Kyoto, in Buenos Aires, and in the Netherlands. This means that any modest success that we enjoy at limiting our emissions will be completely offset by China and other nations. We cannot afford to stall our own economic development when other nations will not be similarly handicapped. Today's hearing, like the hearing we had last month, is focused on dire predictions relating to climate change. These concerns are important, but we could just as easily be focused on dire predictions about our ability to meet energy demands or to meet the growing economic challenges of globalization. These three challenges are deeply intertwined, and our solution to them needs to be comprehensive and address all of them. USGS's most recent report on polar bears and sea ice is in some ways encouraging. While the report indicates that both sea ice and polar bear populations will decline over coming decades, the report does conclude that there will still be a viable polar bear population even a century from now. It's also encouraging that many of the problems we are facing, from the national security implications we discussed last month to the polar bears, sea ice, permafrost, and spruce trees we are here to discuss today, they are all symptoms of the same underlying problem. As we develop and implement technologies for alternative energies, we reduce the threat from all of these symptoms. And I am confident that we can reduce these threats with a comprehensive approach that meets our energy needs and strengthens our economy. I yield back the balance of my time.
Thank you, Mr. Sensenbrenner. If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. And now I would like to introduce our witnesses. Dr. Richard Alley is the Evan Pugh Professor of Geosciences at Pennsylvania State University. Dr. Alley appeared before the committee to testify about the findings of the IPCC report earlier this year. Today he will testify about matters including sea ice, the impact of albedo, and ice sheet melting. Dr. Glenn Juday is a professor of the School of Natural Resources and Agricultural Sciences at the University of Alaska in Fairbanks, one of the world's leading centers for the study of the Arctic. He will discuss recent climatic changes in Alaska, including those in the permafrost, and what we do and do not understand about the potential release of carbon and the boreal forest. Dr. Sue Haseltine is the Associate Director of Biology at the U.S. Geological Survey. She will discuss the findings in its study on the population projections of the polar bears for the next century. Ms. Kassie Siegel is the Director of the Climate, Air, and Energy Program at the Center for Biological Diversity. The Center initiated a lawsuit under the Endangered Species Act that resulted in the proposed listing of the polar bear as an endangered species and resulted in the USGS study. She will discuss the Center's proposed rapid action plan to address Arctic meltdown and to save the polar bear. As our witnesses should know, your full written statement will be placed on the record, and your oral testimony is limited to 5 minutes each. We will give you a little forgiveness on that, but try to pay attention when you see the red light come on. It is also the practice of the subcommittee to take testimony under oath. Do any of you have any objection to being sworn in? I have to say, it seems unlikely to me that any testimony at this hearing would result in perjury charges, but we do want to put you under oath. Just relax at that prospect. And to relax you further, we also always ask if you are represented by counsel today. You're entitled to be represented by counsel. Do any of you have counsel today? You're all on your own. Okay. If you now please stand and raise your right hand. Do you swear to tell the truth and nothing but the truth? Thank you. Dr. Alley, you may begin.
Thank you for the honor, Mr. Chairman, honored members and guests. I had the very good fortune to assist the U.S. National Academy of Sciences and the Intergovernmental Panel on Climate Change in their overarching assessments of the issues of climate change. Those assessments have shown us with high scientific confidence that our activities, fossil fuel burning especially, are changing the composition of the atmosphere, that this is changing the climate, that the changes that have happened so far are very small compared to the changes that will occur under business as usual, and that these coming changes will have very large impacts on ecosystems and economies. This is science. It is not revealed truth, and there are, of course, uncertainties related to this. Unfortunately, what we find is that around that central estimate, things might be a little bit better, they might be a little bit worse. We have not yet found a lot better, but we have found the possibility of a lot worse. That is especially linked to this issue of abrupt climate changes or thresholds or what are now called tipping points. And in looking at the tipping points, the Arctic is a center of focus. I'd like to mention a couple of these. One of them is close to my own research on the Greenland ice sheet. The Greenland ice sheet can exist in part because it is so high left over from the Ice Age that the top is cold. If you make it too warm so that you lower it enough, a little bit of warming lowers the surface. That makes it warmer yet. A little bit of cooling does not get you back to where you had been, and the ice sheet is no longer survivable. We know of no way that you can melt a Greenland ice sheet in mere decades. It would be longer than that. But it remains possible that we will reach a temperature over the next decades which will cause melting of the Greenland ice sheet. Greenland is about 23 feet vertically for the world's ocean. It would certainly arrive much more slowly than what we saw in New Orleans, but just as a scaling, the deepest water in New Orleans after the hurricane was 20 feet. And so Greenland would be more water than that for all the coasts of the world if we tip it over. Another tipping point that comes out of the Arctic is the issue of changes in the North Atlantic circulation. In fact, the IPCC said we have 90% confidence that that won't happen, but 90 is not 100. We know in the past that when a lot of fresh water was being put into the North Atlantic, sometimes very large and surprising things happened. One of the outcomes of those large and surprising things was a notable drying in places where now some billions of people rely on rain-fed agriculture. So in the unlikely event that the meltwater from Greenland should tip the North Atlantic, there's potentially very large consequences. The discussion you will hear coming down the line here on sea ice, we've seen reduction in sea ice. We've seen this year a remarkable reduction in sea ice, and it is losing the thick ice that has an easier time surviving for years. And so the possibility exists as you shrink that sea ice, lose the thick ice, soak up more sun because you don't have the reflection, that we tap into a situation in which the summertime sea ice is gone for long periods of time and hard to get back. You will hear some of the impacts. This clearly affects ecosystems. It opens resource exploitation. It opens shipping. It opens coastal villages to waves that had been blocked by the sea ice, and quite a number of other changes. And it may propagate into the climate of the lower latitudes with possibly interesting results. An analogy for predicting this is going to be difficult. You know that if you sit in a canoe and you lean a little bit, that the canoe leans a little. If you lean a little more, at some point the canoe flips. Telling exactly where the canoe will flip is very difficult, and we can prove that because people fall in sometimes. They can't predict that. Now, we're changing the atmosphere, but we're changing many other things as well, and nature certainly is out there changing things as well. And so the analogy really should be trying to predict when one might flip a canoe while having a large and rambunctious golden retriever bouncing around in the boat with you. This makes it much more difficult, and there will always be uncertainties in these predictions. To summarize, then, we have high scientific confidence that our fossil fuels and other activities are changing the atmosphere, that this is changing the climate, that the changes we have observed so far are small compared to the changes that will come under business as usual, that this will have large impacts on us and other living things that will grow to be very costly. And as has been mentioned, there are options for solutions. This is science. It has associated uncertainties. Unfortunately, because of the existence of tipping points and other things, more of the uncertainty is on the bad side and less of the uncertainty is on the good side. Thank you.
Thank you, Dr. Alley. A better analogy might have been a Labrador retriever. Dr. Juday.
Thank you. Good. I just want to point out at the beginning that I'm bringing information that was requested from Vladimir Romanovsky and John Walsh as well, who are specialists respectively in permafrost and sea ice, and I'll try not to misconstrue the information, and comes from publications that I have cited in the presentation, and if there are more detailed questions, I can certainly have them respond if it goes beyond my expertise. I'm the forest guy. Oops. There we go. Okay, first on permafrost. Permanently frozen ground, or at least ground that's remained in the frozen state for 2 years, underlies a significant part of the northern portion of the planet, and in certain places can contain large lenses of pure water ice, but a lot of frozen organic material. We recognize 3 kinds of permafrost: the continuous permafrost in the coldest portion, the discontinuous permafrost, where the temperatures are marginal and local site factors take over the determination of whether you're going to stay in the frozen condition or not, and then in the southernmost extent, only the very coldest spot localities in the landscape have permafrost. Permafrost temperature measurements has not been a big field in science, and very few people have done that work. Dr. Romanovsky is one of them, and taking over some early work started by Dr. Tom Osterkamp. Here you see a plot of the actual frozen ground temperature trends since the late 1970s, so we have about a 30-year perspective. The trend is up. Equations that predict the temperature of permafrost work exceptionally well with just a few input factors. Air temperature, obviously, is one of them, but snow cover is an extremely important one. And we've seen a very strong rise and then a kind of a leveling or even a backing off a little bit because of trend toward decreasing snow cover. All the models say more snow cover under the warming Earth, and all the data say, not quite all the data, but a significant number of stations that had less. Here's a depiction of nearly a century worth of air temperature data from central and south central Alaska. You see that permafrost forms in the region when the mean annual temperature is between 0 C, 32 F, and 2 below. And you see that in the Talkeetna area in south central Alaska, with the decisive move of temperatures about 30 years ago in the regime shift, we're completely out of that zone. And in central Alaska and Fairbanks, about half of all years are spent in the zone where at least some thawing will begin. So what does this mean? Just allowing for not an acceleration, but a continuation of recent trends in temperatures. The red areas depicted here would be those that would thaw ultimately. Again, there's a long lag effect because there's a lot of insulation power in all of that material that's on the ground, and it goes some depth into the ground, but the initiation of thawing would begin in the areas depicted then. Now, so what? Big deal. Who cares? Well, it's a big deal for a couple of things. Linear infrastructure is the thing most at risk. Railroads, roads, pipelines, because you have to get from point A to point B, and avoidance is not an option. Okay, so that means you got to deal with it. It can be engineered. That's a cost. Some structures, such as the pipeline, advance the technology of dealing with permafrost with natural convective cooling fins and things, but those were designed for a given mean annual temperature. They're engineered for it and achieving a certain amount of cooling, and a careful look may need to be paid at the design capacity of those systems. Now, buildings and building footprints on permafrost can be a significant problem. If the building is small and low value enough, maybe a low-cost solution like just adjustable foundations can work. In other cases, if you're going to put a major investment in the ground, you're dealing with probably something else entirely. Now, perhaps a more global significance is the role that thawing the permafrost is going to have in releasing, as you pointed out, Mr. Chairman, the greenhouse gases into the atmosphere. Spontaneous thaw of permafrost is observable on the landscape today, as you can see. It can come out in two different forms. One, CO2, when the decomposition is aerobic, but it can also come out as methane when conditions are anaerobic. And as lenses of ice thaw and then melt, the ground subsides, fills with water, creates anaerobic conditions, lack of oxygen. What comes out is methane. It generally has been vastly underestimated in the past. And the reason is it comes out in a way that's hard to measure, and that is these bubbles. Here you see the bubbles trapped in clear water ice. That methane, of course, is an extremely powerful greenhouse gas, and per unit volume is 21 times more powerful in producing a greenhouse effect. This now, collapsed ponds and ebullition, or the bubbling up of methane, is a widespread phenomenon observable in parts of Alaska and in Siberia. So, what does this all mean? Let's get some numbers on the table here. As you pointed out, gigatons of carbon per year. Recent years, we've been combusting about 6.3. Essentially permanent land use change in the tropical forest regions has been usurping the uptake so that we get 7.9. However, fortunately for us, uptake and storage on land has been about 2.3 and a similar amount in the world ocean, so that the net problem that we experience is an uptick of 3.3. which is considerably less than the 7.9. I'm afraid I have to tell you that there's every indication that the ability of land ecosystems to store carbon is going down, and probably down very significantly, and they very soon could be net neutral. Now, in terms of storage, it's just a slightly different story. The tundra and arboreal systems are pretty good at growing plant material, but really not so good at decomposing it because of the cold soils. The tropical forests are some of our most productive systems on Earth, that is, uptake of carbon, but they decompose just about the same amount, very low storage. So, in that storehouse, that locker of carbon that makes up the ground layer in the cold regions, we're seeing some, well, very momentous developments. For example, last month we had a September tundra fire, extremely rare event, and it was not a small one. It was a very, very large one. It was over 175,000 acres. You can see the footprint of the fire on the north slope of Alaska here. We have a reasonable record of fire, wildland fire in Alaska for 57 years, and the record has not been kept according to the fuel type that burned, whether it was tundra or whether it was forest, But I asked the Alaska Fire Service, and they produced this statistic. If you draw a line at 68 north of that, there just generally aren't forests. So let's focus on that, and we'll be sure that we're getting a tundra signal. This is as clear as the evidence gets. There were not tundra fires. Then came a period when, at peak warmth, we had 1, 2, and now a very substantial increase in tundra fire. Now let's transition a little further south to the boreal forest. That's that belt of conifer-dominated forest land south of the tundra. It has this tilt to it so that in western North American boreal is further north and more productive at an equivalent latitude than in eastern North America, and that's because of the introduction of warm air from the south by the storm systems and its export with a little boost from the cold ice regions of eastern North American Arctic. This is a graphic I actually produced for the select committee that I testified to 2 weeks ago. We were going to the stand when we had to cancel the trip this summer, but did have the hearing. And in that stand that I've been monitoring for 20-some years, I just plotted the predictive index of temperature that tells us how much the forest should grow versus the ring width, which is the vertical axis there of this sample. And you can see that warmer, less it grows. The interesting thing is where the index doesn't work, for example, the forest grew less than the prediction. There's a good reason for that. For example, spruce budworm outbreaks, the trees covered with volcanic ash. Here's a record warm summer, 2004, which predicted the growth in 2005. And you see there is a zone of uncertainty around the trend line, which means that we are extremely close to what you could call the kill zone, lethal temperatures, where the trees would spontaneously die in the forest because it's just too warm for their adaptive capabilities. You can see that's about 1 degree C. Now, is that a local phenomenon? Is that just something I found in my plot, in my forest? This is a satellite-observed photosynthetic trends measured from 1980 through 2003 by Scott Getz. And these are pixels depicted here, 10 by 10 kilometer chunks of the Earth. And if during that period of time the photosynthetic trend was down or strongly down, it's colored blue. And as you can see, the entire boreal forest of North America shows a considerable amount of blue or neutral, no large increases. We are seeing things, for example, such as the spruce budworm now exhibiting outbreak behavior. It's an insect that hatches, feeds on the foliage like this, and leaves the tree in this condition after it's done feeding. And there's a direct temperature control. It's a major insect species in the Canadian boreal forest. We have never seen it in outbreak mode in the northernmost boreal forest. Now it is. Temperatures were too low, now they're warm enough, now it's killing the trees. You can see clearly a record in the tree growth. There's the 2005 hot, dry year. There's the spruce budworm outbreak. This is killing the growth of the forest. But that's not all. Here's leaf scorch on birch trees. It's the last symptom to appear before the tree dies and when it's running out of water. A three-tone color in which there's death or necrosis of tissue around the margin, then the breakdown of chlorophyll so that you have the yellow zone, and then finally the green is retained only around the veins where the water can be first introduced into the leaf. Similar kill zone is apparent in our most sensitive sites that grow birch, and in fact, the 2004 temperature indicating, well, we entered the kill zone. So, do we have dead trees? Yes. The head of the Forest Health Survey took my research seriously, and so he went out and he looked, and he found dead trees that were not killed by insects that apparently were the result of this phenomenon. Fires. We had the record fire year in the season 2004. If you take the northeast quadrant of Alaska, 15 to 20% of all forest land burned in 1 year. Then, something very close to that happened the next year, another 7 to 10%. So in a 2-year period, we had 1/4 to 1/3 of all forest land in the northeast quadrant of Alaska burned. Finally, I'll just do a couple of comments about sea ice. It's going to be the subject of a lot of discussion from a couple perspectives here. This is the depiction of the sea ice cover as of, I think it's a week and a half ago. You see the long-term mean in the upper black line. The dashed line was the previous record low, the 2005 record, and you see 2007. 25% below the previous low record, which was set only 2 years ago. Here's a depiction of the seasonal and annual sea ice extent. There are 2 different standards for measuring this. In case there's some confusion, some of the numbers that are thrown around, just be aware of that. There's the sea ice edge and extent, and there's also total sea ice cover, which accounts for leads and openings further north. But as you can see, a radical reduction in a 1-year period in the sea ice cover at the end of the summer. And perhaps as significant, there are these zones of retreat that rotate around along with the movement of the ice in the polar gyre that have brought open water conditions very far north in the past, but usually in a lobe or a finger in one particular sector of the Arctic. But during the period of the satellite record, no open water has ever been seen in the area depicted here, and that was entirely free of ice and contiguous with other open water all the way to the south. Last point I'll make is the little community of Shishmaref. You may have heard of it. I had the opportunity to, in the hearing 2 weeks ago, to be accompanied by Mayor Stanley Took, who's mayor of this community. And just to give you a picture of what they're dealing with, these are self-reliant people who work hard. They engage in hard physical labor, not for cash, but for a considerable period of the year to get the food they need. They go out on the ice to hunt. They gather, they fish, they engage in these activities, and they can tell you their environment is changing. Pack ice should be present and forming up right about now. It traditionally has been, giving them access to the seals they hunt, and a very important part of their annual diet, and they're not able to be safely on the ice at this time. Open water appearing, for example, as you see here in February, and the erosion that is now possible from the storm and the fetch that the wind has access to churn and push this water because of the disappearance of the sea ice is causing enormously accelerated erosion, and the community is literally being destroyed. So, in summary, the permafrost definitely is warming. The first stages of thawing are obvious. The boreal forest has burned, is sick, or is dying on a very extensive scale. Its ability to store carbon is being severely compromised, and the mobilization of carbon it has previously stored is well underway. Sea ice is retreating and also thinning. I haven't touched on other things such as glacier melting, sea level rise, lakes drying, species movements, etc. But if you have questions on those areas, I'll attempt to answer them. Thank you.
Thank you, Dr. Juday. I did not want to interrupt that because of its obvious importance, but if you would try to summarize some your testimony, it would be helpful to the committee. Dr. Haseltine. Need to turn your microphone on.
Sorry. Thank you, Mr. Chairman and members of the subcommittee, for the opportunity to participate in today's hearing. I'd also like to introduce one of our sea ice researchers from Alaska, Dave Douglas, sitting behind me. Dave was a member of the team that produced the reports that I'm going to talk about today. Global climate change is one of the most complex environmental challenges obviously facing society today. And while climate change is a natural, continuous Earth process, changes to the Earth's climate are also related to human activities, and whether the causes are natural or from human influence, the USGS scientists focus on understanding the impacts of climate change and potential adaptive strategies for managing natural resources and ecosystems in the face of these changes on the landscape. The USGS conducts scientific research to understand the likely consequences of climate change using three primary strategies. First, by studying how climate has changed in the past and using the past to forecast responses into the future. Second, by distinguishing between natural and human-induced changes where possible. And third, by quantifying both biological and physical responses to climate change. Today I want to discuss the changes that have been observed and modeled in Arctic sea ice and their impacts on the top predator in that environment, the polar bear. Data from the satellite record for the past 3 decades shows a decline of about 10% per decade in the minimum annual Arctic sea ice extent at the end of the summer melt season. In this year's melt season, as has been noted, the minimum ice coverage in the Arctic was measured at about 4 million square kilometers. And that represents about 40% less ice than was observed in 1979 when we had the first satellite records. While rising Arctic air temperatures have certainly contributed to this loss of sea ice, there are several other factors that have interacted to accelerate the loss. And there's a growing scientific concern that the synergism of recent events in the Arctic, regardless of their origin, may have already pushed the Arctic past a threshold of cascading change. The USGS and our partners around the Arctic have a robust baseline of data for assessing polar bear populations, for defining essential polar bear habitat in the sea ice, and for making projections of future population status. The 9 recently released USGS reports build on this history of research and collaboration and culminate in a new range-wide forecast of polar bear status under various projections of future climate change. To forecast the status of polar bear population worldwide during the 21st century required modeling information on the future habitat conditions for polar bears and also on their projected population status. We used 10 of the general circulation models that were used in the IPCC 4th assessment report in projecting this change. And those 10 were the ones that most closely mirror the sea ice change that we've observed over the last few decades. We used middle-of-the-road carbon loading scenarios in making our projections. And we developed a future model then that combined information about annual and seasonal sea ice change, habitat preferences for polar bears, and population demographics to predict likely polar bear numbers and distributions into the future. The model results show that by the mid-century, polar bear populations will likely be extirpated from their southernmost range in southeastern Canada, as well as from the Arctic regions bordering Alaska, Russia, and Europe. By late century, populations in East Greenland and the North Beaufort Sea will also likely be gone. And as stated before, these regions now support 2/3 of the worldwide population of polar bears, which is estimated at between 20 and 25,000 animals. However, the models also predict a strong likelihood of polar bears surviving in the high Canadian Arctic, which may provide a source of animals to reestablish former ranges if the Arctic's sea ice environment is restored to present conditions. Preliminary USGS analysis of other carbon loading scenarios indicate that less atmospheric carbon dioxide loading does not substantially change outcomes for polar bears through the mid-century, but does result in less loss of sea ice and thus polar bear habitat by the end of the 21st century. At the USGS, we recognize that the momentum of atmospheric greenhouse gas loading will challenge us with climate-related issues for at least the next 50 years. A better understanding of sea ice must be combined with an understanding of ecological response and adaptation to provide the best information to decision makers. We believe that outputs from coupled physical and biological forecasting approaches, as presented in our recent reports, will better inform decision makers as they address climate adaptation. Such forecasting will require continued long-term monitoring of both sea ice and ecological response, focused studies of ecological processes in response to climate change, and the application of many new and emerging modeling approaches by scientists with many different specialties working together. Thank you for the opportunity to present and address you today.
Thank you, Dr. Haseltine. My great fear is that Mr. Rohrbacher is going to think that the indulgence that I'm showing today on time limits for witnesses' testimony will also apply for the time limits for members' questioning. Ms. Siegel.
Good morning, Mr. Chairman and members of the committee. Thank you so much for the opportunity to testify. Early next year, the polar bear will likely be listed as threatened or endangered under the Endangered Species Act. While enormously significant both legally and politically, the listing of the polar bear will not in and of itself be enough to save the polar bear or its Arctic sea ice habitat. Last month, the Arctic sea ice reached a stunning new minimum. The sea ice looked like this in September 1979 and like this in September 2007. This is a loss of 1 million square miles off the average minimum sea ice extent of the past several centuries. And the melt is happening faster than forecast. This slide shows climate model predictions of sea ice extent in the dashed colored lines compared to actual observed sea ice extent in the heavy red line. Sea ice in September 2007 was far below what any of the models predicted, and perhaps most worrisome, there was less ice in the Arctic this year than more than half the models project for 2050. The polar bear is a creature of the sea ice and needs sea ice for all of its essential behaviors, including traveling and mating and hunting its primary prey of ice-dependent seals. Polar bears cannot hunt seals from land, and so tied to the ice are they that some mother polar bears even give birth to their cubs in snow dens like this one on top of the drifting ice. Polar bears cannot survive without their Arctic sea ice habitat. The situation for polar bears in a rapidly warming Arctic is grim. Polar bears are drowning, resorting to cannibalism when they don't have access to their usual food sources, and starving. This photograph was taken in northern Quebec, Canada last month. This bear is in the final stages of starvation. While we cannot say for sure that this bear died as a direct result of global warming, we do know that global warming is increasing and will continue to increase the number of bears that suffer this fate. But we also know that it's not too late to do something about it. Motivated by the need to do so, the Center for Biological Diversity filed a petition to list the polar bear under the Endangered Species Act in February 2005. The listing process has already benefited the species by raising awareness of its plight and leading to new information, such as the U.S. study which predicts the extinction of 2/3 of the world polar bears by 2050, which was conducted in support of the listing process. The Arctic has reached a critical threshold, and our window to act, like the ice itself, is melting rapidly away. But it's not too late. The grim projections from the USGS are based on the A1B IPCC emission scenario, in which CO2 concentrations reach 717 parts per million by the end of this century. We know that business as usual cannot continue, and we must limit CO2 concentrations to below 450 parts per million. We need deep, rapid, and mandatory reductions in CO2 to save the polar bear. But the Arctic has advanced so far towards a tipping point that CO2 reductions are now necessary but not sufficient to save polar bears. Anything else we do may be futile if we don't address this most important of greenhouse gases. CO2 has a long atmospheric lifetime, so the benefits of CO2 reductions today will take a long time to be fully felt. We need a way to buy ourselves some time. Fortunately, we have an opportunity to do just that by addressing methane and black carbon emissions, both pollutants with short atmospheric lifetimes and a very high warming impact in the Arctic. By attacking methane and black carbon emissions, we can have a short-term benefit in the Arctic, and we can provide ourselves with a last and golden opportunity to give polar bears back their future. Methane is a globally well-mixed gas, 21 times more powerful than CO2 that stays in the atmosphere for about 12 years. Methane also leads to higher levels of tropospheric ozone, which has a high warming impact in the Arctic, where it absorbs light energy reflected off the snow and ice. So by reducing methane, we can also reduce ozone levels in the Arctic and provide a double benefit to the region in the short term. Further good news is that there are enormous amounts of cost-positive and no-cost methane reductions sitting on the table today. We have fantastic opportunities to capture methane from landfills and from livestock operations and use it to generate energy, and to reduce methane losses from natural gas systems, just to name a few. According to conservative projections from the U.S. EPA, conservative estimates, we could reduce nearly 70 million metric tons of CO2 equivalent methane emissions in the U.S. by 2010 at a cost-benefit or no cost. That's the equivalent of getting paid to take 12 million cars off the road, and we can do so much more at low cost. But voluntary measures in the market have not provided these so-called no-regrets emissions reductions. We desperately need congressional action. Black carbon, or soot, is emitted from the inefficient burning of fossil fuels, biofuels, and biomass. We have opportunities to reduce soot from sources such as diesel fuel and coal-fired power plants. Soot remains in the atmosphere for only about 5 days, but it has an extraordinarily powerful warming impact of about 500 times that of CO2 over a 100-year period. It's particularly important to address within Arctic sources, like diesel generators and ship engines. The rapid melting of the Arctic is the Earth's early warning system, and yet, like beachgoers chasing the receding waters immediately prior to a tsunami to gather up the exposed shellfish, nations and industry are racing to the newly ice-free areas to stake claims for fossil fuel development and shipping routes that would commit us further down the path to climate catastrophe. To save the polar bear, we must find the courage to not only reduce greenhouse gas pollution, but also to protect the Arctic from further industrial exploitation. We believe that Congress should act immediately to slash methane and black carbon emissions. Methane emissions from landfills, livestock operations, natural gas systems, and other sources should be strictly limited. Black carbon emissions from the use of diesel fuel and coal must also be addressed. These measures will also greatly benefit our economy and public health. We also believe Congress should enact a moratorium on new fossil fuel leasing and development in the Arctic, where these activities both directly impact the species most at risk from global warming and also contribute substantially to greenhouse gas emissions. If we truly act with speed and determination, it is not too late to save the polar bear, to save the entire productive Arctic ecosystem, and to avoid the worst impacts of global warming for ourselves. Thank you.
Thank you, Ms. Siegel. I recognize myself for an initial round of questions. There was a congressional delegation, a CODEL, members of this committee, a couple months ago to Greenland. I was part of the delegation, and it was striking. The scientists we talked to came from a variety of different, what appeared to be different disciplines, that all intersected the Arctic. They all called themselves snow and ice guys, but their disciplines were varied, and it took me a while to realize, yes, that does have an intersection with research on the Arctic. They also all appear to be kind of members of a fraternity. They all knew each other, knew each other's work. They'd hung out together, probably in the few bars there are in Greenland. So they were familiar with each other's work. There's a recent paper on polar bears that paints a much more optimistic picture, Ms. Siegel or Dr. Haseltine. And one of the authors is an astrophysicist, which I've got to say still does not strike me. I still don't see the intersection of astrophysicist and physicism, whatever, astrophysics, there you go, and polar bears or the Arctic. But perhaps there's one that I'm missing. The study was by Dyke, or the paper was by Dyke and Willie Soon, and Willie Soon apparently is an astrophysicist. Is astrophysics one of the disciplines that has an intersection with research into the Arctic or into polar bears? Any of you, Dr. Alley, Dr. Juday, Dr. Haseltine?
I have to say that we have an astrophysics branch at USGS that works with NASA, and we didn't use their models in projecting polar bears.
Okay. I took that as a delicate way of saying no, that you didn't really think astrophysics had a particular application in modeling. Do any of you, Russ, you know of any work being done by astrophysicists that pertain to projections of the climate in the Arctic or the effect on polar bears?
There's been a long interest in trying to sort out what of the changes that are occurring are natural and what of the changes occurring are human caused. And astrophysics feeds into this from one side, because very clearly changes in the sun will affect the climate strongly. And there are hypotheses that are not very well validated that changes in cosmic rays or other things will matter. And so, in fact, we do talk to astrophysicists on the climate end, and their output has been assessed and included in the work of the National Academy or the IPCC in saying with high confidence that the recent changes we see in the Arctic are not astrophysical, they're us.
And how about specifically the effect on polar bears?
I personally, normally when I get to the point of talking about biology, I get a big smile on my face and I show pretty pictures of what I've seen, but I turn to an expert.
Okay. And I assume that all of you kind of know each other before this. You didn't meet the first time today. Is that correct? Okay, you knew of each other? Okay. Knew each other by reputation, at least, even if you hadn't had beers together in a bar on the Bering Sea. Okay. Are you familiar with Willie Soon, Dr. Willie Soon, other than from the recent paper, from research in this area?
Yes, I try to keep up with the comments of the community of what's sometimes called the climo skeptics, and he's been prominent there. Sometimes I get good ideas of how to test some of what I think I'm finding and take a more skeptical eye toward.
Dr. Haseltine, you look like you're ready to say something on this topic. Ms. Siegel, are you familiar with this paper, and what's your take on it?
I am, Mr. Chairman, and I'd like to point out that the paper was funded by the Charles G. Cox Charitable Fund, American Petroleum Institute, and ExxonMobil, and that the authors include discredited climate deniers Willie Soon, David Legades, Sally Baliunas, and others. I'd also like to point out that it was published as a viewpoint in the journal Ecological Complexity, not as a peer-reviewed science article. This is essentially an op-ed masquerading as a peer-reviewed science journal. The article was also based on the assertion that there is no significant warming trend in western Hudson Bay, which is simply not true. Breakup now occurs 3 weeks earlier in western Hudson Bay than it did 30 years ago. The sea ice is in fact declining in the Arctic. From late spring to breakup is the most important hunting time for polar bears when they eat large numbers of ringed seal pups. They now have less time on the ice to hunt. Body condition and cub survival have declined, and female polar bears that do not reach a certain minimum body weight cannot reproduce. The population has declined 22% from 1,200 bears in 1987 to less than 950 bears in 2004. Leading polar experts have said that suggestions that today's polar bear populations will be able to obtain food sources to replace seals caught on the ice surface is fanciful. Polar bears in western Hudson Bay during the ice-free months are in a hibernation-like state, physiological state of fasting. They cannot replace extremely energy-intensive seal blubber with berries and opportunistic scavenging. Leading polar bear experts have stated that we must quickly and significantly reduce greenhouse gas emissions in order to save polar bears.
Thank you. My time has now expired. Mr. Rohrbacher.
Thank you very much, Mr. Chairman. Siegel, your degree in educational background. Can you push to?
I did my undergraduate work in anthropology and economics, and I am an attorney.
So you have an undergraduate degree in
anthropology and economics from the College of William and Mary in Williamsburg, Virginia.
I couldn't find that in your bio here. It just you went to Bolt Hall?
Exactly, Bolt Hall at the University of California.
Right, I know that. That's in Berkeley, is it not?
That's correct.
The chairman quoted Mr. Hansen earlier, Dr. Hansen, and I understand that Dr. Hansen has received a substantial amount of money for his research from George Soros, who is of course, to say he's politically active is to put that mildly. Has anyone else here, or the organizations you're associated with, or you yourself, received money from Mr. Soros or his foundations to do your research or your activities? Hansen, has your organization received any money from Mr. Soros?
Not to my knowledge.
My knowledge. Very loyally answer. Okay. There is no question, obviously, that the Earth is going through a warming trend right now. No question about that. One realizes that the Earth's warming trends perhaps dozens of times. The major question is this warming trend caused by human activity? If it is not, could we not be looking at adapting rather than arrogantly thinking that mankind can reverse what has been a trend of nature over many hundreds of thousands, if not millions of years of the planet? Let me just state that, and of course we're looking at the effects of this in terms of polar bears, etc. One of the reasons some of us, like myself, are skeptical of some of these things is just that I remember very much the predictions of dire and doom for the caribou. We ended up building a pipeline across Alaska. I don't have to ask you, you all know that the caribou population has dramatically expanded since that pipeline, although people were testifying before Congress and just as adamant as yourselves that the caribou population was going to be decimated by the pipeline across Alaska. Quite often we hear people with these dire predictions in order to whatever accomplish perhaps other political ends. Soros has in mind. Let me ask this: what? We know that ice cores and these things are suggesting that give us an understanding of change in the planet. Apparently, Dr. Timothy Ball, who is a former climatology professor at the University of Winnipeg, stated that the theory, and I quote, "In theory, the claim that if CO2 goes up, temperature will go up, wrong. The ice core record last 420,000 years shows exactly the opposite. That indeed, increases in the temperature bring about more CO2 rather than CO2 increases bringing about the increase in the temperature, which of course leads directly to whether or not humankind is actually causing this increased temperature." Now, Dr. Juday, is that how you pronounce your name, sir? Was mentioning how the methane gas is bubbling up as the temperature increases. Seems to me your testimony backed up Dr. Ball's observation, because what you were saying was as the temperature has gone up, there's more methane being put into the atmosphere, and it would be as wrong to say that methane increasing in the atmosphere was causing the temperature to go up. Is that correct?
Yeah, sir. If I were to take my credit card and overspend, I would go into debt, and then I would start to make interest payments, which would contribute to my debt further. If your accountant were to try to understand my debt based solely on my overexpenditures, your accountant would fail. If your accountant included the interest payments that were triggered by my going into debt, your accountant would succeed. What we know very clearly is that the ice age cycles referred to by Dr. Ball are caused by features of Earth's orbit. For example, caused by features of Earth's orbit. Imagine that you're the sun for a moment.
Right.
This is the Earth. My North Pole, if it stood straight up, would never get a sunburn from your brightness. But because it's inclined, I can get a sunburn on my North Pole. And the North Pole nods over 41,000 years. More sunburn, less sunburn. Okay? That plus a wobble and a change in the shape of the orbit cause the ice ages. But those changes from the ice age cause changes in CO2 and in methane. And when we try to explain the very large change in temperature on the planet for the ice ages, if we assume that CO2 and methane do not cause warming, no one has ever explained how big the changes are, in the same way that your accountant could not explain my debt without including my interest payments. If we use the warming that's expected from the CO2 and the methane, we explain what happened. And so in exactly the same way that the interest payments on my debt contribute to my debt and must be included to explain my debt, the interest payments of CO2 coming up with the warming contribute to further warming and must be included to explain that warming.
You know, I'll have to admit, I don't understand a thing that you just said.
You can ask further in the next round of questions.
But I would say that you did tend to indicate that the climate change that we've seen in the past, at least, was caused by changes by the sun and by changes in the earth, rather than by human activity.
Very clearly, the ice age cycle is not to our credit. It is nature.
Thank you, Dr. Juday, I think, does want to respond as well. Dr. Juday?
I was trying to get the point across that there are these amplification mechanisms, and the initial push it can be, in the short term, solar variability, volcanic eruptions of a particular kind that can cool things down, and the coupled atmosphere marine circulation patterns. I have a slide that is in the post-presentation phase there where I did a test of this, And it's a long-term record, starts in 1917, and it shows the date of ice breakup on the Tanana River in Alaska. The crews that were building the Alaska Railroad got bored, and so they did a lottery, and one of this thing, and to the minute, it's been done exactly the same way ever since. And by accounting for just exactly those factors, solar variability, the solar cycle, the big El Niños, and the couple of really big volcanic eruptions that we've had, take those out of that record, and they have a dramatic impact. When it's supposed to be cold, boy, they make it cold, and the breakup is late. And when it's supposed to be warm, boy, they make it warm. Take them out. And what's left is a trend. And the only way to explain that trend is there's some underlying process. If you look further at the character of that process, what do you see? The daily high temperatures haven't changed all that much. The daily low temperatures have increased at the rate of 3 to 3.5 C per century. Our growing season length has doubled. The winter temperatures have warmed. So something is happening that's dampening heat loss, not adding extra heat during the summer or the hot year.
The only question is whether it's a human
Those
or not.
characteristics are exactly the characteristics of the way a greenhouse gas process works. So it matches, and if there's a better theory, I would pursue that.
Sun.
All right, a couple points quickly. Dr. Hansen, I understand, denies the allegation that he has gotten money from Dr. Soros. He is not here to defend himself. He is not a witness here today. He is a scientist at NASA. My understanding is he's one of the world's leading climate scientists, but he is in charge with having received money from Mr. Soros, from George Soros. He says that is not true, and we have a statement from him actually, in which he said that is not true. So we will now enter that into the record. I have a peculiar question that may take you a while to think about, because we all know people named Steve, but it may take us a second to think of who they are. There is one of the frustrations of dealing with what scientists think is that there are so many scientists. But there is a science blog called Panda's Thumb that has done kind of a canvas of the scientists named Steve. I thought that was a more workable number of people. And when there is a dispute about what scientists think, rather than try to canvass all scientists, they try to canvass the scientist named Steve. An intriguing idea, and one that probably makes statistical sense. It's probably a statistically valid sample. Do you all know any climate skeptics who believe that either the globe's climate is not changing, is not warming, or that the cause is not human activity, named Steve? Okay, you can get back to us on that.
I'm finding one right now.
Right. How about scientists named Steve? Can you think of scientists named Steve who believe that the world's climate is changing? It is a result, and it is warming, and it is a result of human activity. Named Steve. Dr. Alley?
Stephen Schneider, Stanford would be a good starting point.
Okay. Dr. Juday, any Steves come to your mind?
Yeah, those are the one I thought of.
Okay. Dr. Haseltine?
Well, I would say Steve Amstrup, who's our lead polar bear biologist in Alaska and experiences conditions in the Arctic out in the field every year.
Okay.
Certainly believes that the climate is changing in the Arctic.
So it's 2 to 0 among Steves that you can think of. Okay. But you all can think of other Steves and get back to us on what the Steves the scientists named Steve think. Dr. Alley, I understand that the IPCC probably had some difficulty of kind of projecting exactly what the processes were that would lead to the cascading effect, the tipping points that you talked about. How well are they accounted for, and particularly the ones we talked about today, the melting of the permafrost, the release of carbon dioxide and methane from the permafrost? How well was that, or how much was that considered in the IPCC modeling?
It is not well included in the IPCC modeling. In fact, there's a statement in regard to the sea level rise that because of lack of inclusion of these carbon cycle feedbacks, which is what you're referring to, and because of lack of inclusion of understanding about the changes in the flow of the ice sheets, that they can provide neither a best estimate nor an upper limit on what sea level will do. And those were the two uncertainties that were especially highlighted.
Anyone else on that? That seemed to be a question for Dr. Alley more than anyone else. Congratulations, by the way, on winning a Nobel Prize.
Yes, Mr. Chairman, I think to squeeze the last bit of uncertainty out of that question, we have one more piece of information that we need, which is we need to poke holes in the tundra and see if there's charcoal in them, because the fact that we're seeing fires now, and it is warmer now, and that makes it flammable, doesn't quite rule out the possibility that it happened before. It's not reported, it's not known. Everybody that I've spoken to who works in charcoal in the base of the tundra, no. But we have to do that work in order to be absolutely confident that this isn't already dialed into the system that we have now.
Well, I will actually set an example and not use the last 18 seconds of my time. Mr. Rohrbacher.
Thank you. I don't have any scientists named Steve, but I certainly have numerous other scientists who don't believe in that the global warming that's experiencing today is humankind, or human-caused. Let me also note there's a scientist named Patrick Michaels, who was a former chairman of the Committee of Applied Climatology of the American Meteorological Society, who suggests that all these reports of all the ice on Greenland are totally exaggerated. Quote here from
Congressman, if I just to clarify what I intended my response to be, that all of the factors that can produce the warming and cooling happen all at the same time, and all I was saying is that you have to account for all of them. It's a good thing when you're trying to quantify one to isolate it and see what strength its effect is, but then don't make the mistake of going back and saying, oh, and then the others don't happen. They all happen at the same time.
Well, all I can suggest is there's a lot of a lot of very, very well-known scientists, respected scientists throughout the world, people, especially in the senior levels, who are made that they believe that their fellow scientists have been influenced by the desire to get government grants for funding, and the fact that since Bill Clinton became president of the United States, all those years back, that in order to get those grants, you had to be caused by human beings. I have a statement here, several here of scientists, Dr. Mitch Taylor, polar bear biologist at the Department of Environment there in Canada, and he's suggesting that the polar bear population is not going down. In fact, in 13 populations of polar bears in Canada, 11 are stable or increasing in number. Another quote suggesting that the polar bear numbers were actually underestimated prior years, and thus now, in fact, are not seeing this decrease as is suggested today. Are these two scientists just off, or?
Well, I could respond to that. I believe the 13 populations that you see quoted there are the 13 that at least have some of their territory in Canada. That's the number in Canada. And in the reassessment that we did over the last year, 5 of those populations are declining. 2 of them are depressed from overhunting. Several of them are stable. I don't remember the exact number. and none of them are demonstrated to be increasing. So that's
Okay. So, Dr. Taylor, the head of this department there, whose job it is to keep track of this, this isn't just a side test, this is what his job is wrong, and you're right.
Well, I'm quoting from the results of the study in a recent article by Ian Sterling.
This is the study by the Geological Survey.
Right, and a recent article by Ian Sterling, who's one of the senior polar bear researchers for the Canadian Wildlife Service.
So,
And so I think that this individual who works in with Nunavut territories in Canada is just using older information.
Okay, well, let me put it this way. There are experts who are not named Steve who are disagreeing with what the findings are of the people today. But let us just note this, that, again, the central issue is whether or not all of these things are caused by human activity or not. Just coincidentally, 2 nights ago, the History Channel again ran, but it updates quite often, is its long documentary on the mini ice age. And one of the facts I noticed there, what they presented, which is, again, showing how 1,000 years ago it was a lot warmer up in Greenland and Iceland and these places, and maybe a lot warmer than it is today. And in fact, I don't know what the polar bear population was at that time, and I'm not sure if that's not the natural number of polar bears we should have in the world as compared to now. But they did note that they said that volcanic activity during the mini ice age was about 5 times greater than it has been over the last 150 years. And that volcanic activity, which they then went into with their scientists on the History Channel, were indicating that with volcanic activity, you actually, it creates a situation where the Earth would be warmer without that volcanic activity because it reflects the rays of the sun. So here we have only 1 degree or maybe 1.5 degrees warmer over that 150 years since the end of the mini ice age, and yet we have 5 times less the volcanic activity, which would tend to make it a warmer situation. So there is even one, not to mention sunspots or whatever else, there is a natural explanation for this as compared to the fact that we're driving in SUVs or we have industrialization, which of course in no way can explain the warming that's also going on Mars and Jupiter. So why is it that we should be so concerned and trying to regulate human activity to save the polar bears when all of this may be just a natural occurrence?
I was relieved to hear the word "why," suggesting that there was actually a question there. We're now over the time, but if you could respond briefly.
I was the lead author in the chapter of the Arctic Climate Impact Assessment, in which we reviewed the evidence based on tree ring studies that gives us essentially a complete record for 8,000 years. It shows the ups and the downs of the climate, and I just refer you to that if you'd like to go through what's happened when, and that's available. You can download it, www.acia.uaf.edu. You've brought up several different ideas there, and I just offer to talk to you to help untangle some of them and distinguish between 2 things: the empirical fact of what's happened and the interpretations of why, the attribution.
Just to add, as you know, scientists float all kinds of wonderful ideas and smart ones and crazy ones, and we bubble with ideas, and then you help pay for activities that seek to assess these and to give you sort of what stands solidly and what is not solid. And those activities often come out of the National Academy of Sciences. They come out of the Intergovernmental Panel on Climate Change. Those groups have assessed these. They've looked at the effect of volcanoes, the effect of sun, the effect of other things, and come to high scientific confidence that, in fact, you see our footprint now in what is going on. I would also like to add, and you were quoting a scientist earlier, suggesting that perhaps we are torquing our research to gain government grants and that we might not be completely honest in what we're doing. Sir, personally, I'm under oath. And I would never, ever, ever do that, and I do not believe any of my colleagues would do that. Rest yourself absolutely assured that we are trying our hardest, and we are not lying to you,
I will
sir.
submit for the record at this point then several quotations from very respected scientists making that suggestion, others who have, and the reason,
I'm under oath.
skewed research, et cetera, in order to get government grants to approval. Happy to submit those for the record.
Please do that. And Mr. Orbach, you have promised to provide that list on several occasions for the record, and we've not gotten it at previous hearings, but we will certainly be happy to take that. Okay. Well, it now appears that George Soros and ExxonMobil may be in a desperate competition to identify a scientist named Steve, whose research they can fund. Ms. Siegel, it's true that you're not a scientist on this panel. You are a lawyer, but it appears that your testimony was the most hopeful of the testimony that we have heard today. The three scientists were less hopeful, or their presentations were more grim than yours. But I do have a couple of questions about what we can be doing, which is part of your testimony as well. There's a landfill in my district, in everybody's district, but in this one it's being closed up, it's being covered over, and they are still pulling off the methane and piping it a mile or two away to a manufacturer who then uses that methane and burns it for energy. What is it that governments and corporations and individuals can be doing and are doing that would significantly reduce methane?
Thank you, Mr. Chairman. As you mentioned, we have enormous opportunities to reduce methane from the waste, the agriculture, and the energy sectors. One of the most important things we can do in the waste sector is to divert organic materials from landfills through composting, recycling, and reuse programs. Where that's not feasible, methane can be captured from the landfill gas and used to generate electricity. The U.S. EPA estimates that 88%, or 110 million metric tons, could be abated this way in this country by 2010, and that 10%, or 12 million metric tons, could be abated at a cost-benefit or no cost. We can also capture methane from wastewater treatment plants and use it to generate electricity. The biggest opportunities are in the developing world, where the EPA estimates there are approximately 600 million metric tons of CO2 equivalent methane emissions reductions sitting on the table. We don't have cost estimates for this, but it is clear that expanding wastewater treatment facilities in the developing world will have enormous public health benefits for disease prevention and greatly reduce methane emissions. In the energy sector, we also have enormous opportunities. One of the primary sources of methane from natural gas systems is through the leakage from lines and equipment, and there's many, many different measures that fall into three categories, including operational changes, equipment upgrade and replacement, and better inspection and maintenance. And over 50% of methane emissions, or 76 million metric tons, could be abated this way with technology available today. 14.5%, or 20 million metric tons, could be done at a cost benefit of up to $25 per metric ton from the natural gas sector. Methane is also released from coal mining because methane is produced when organic matter turns to coal and is present in coal seams. We need an immediate moratorium on new coal-fired power plants and to ultimately phase out existing plants and therefore coal mining as well. But nevertheless, it's foolish to allow methane emissions to continue where coal mining is still carried out for the time being. Nearly 50% or 25 million metric tons of baseline emissions could be eliminated by the year 2010 in the U.S. at a cost-benefit or no cost. About 86% could be eliminated for less than $15 per ton. Also, in the agricultural sector, we have very important opportunities to capture methane from manure lagoons rather than just letting the manure sit in the lagoons and emit the methane, using something called methane digesters. A digester is a system of containers to collect and biologically treat manure with naturally occurring microorganisms. The methane can then also be used to generate electricity. The EPA conservatively estimates that 11 million metric tons of CO2 equivalent cost-beneficial or no-cost emissions could be abated this way from the agricultural sector.
Thank you. One other question along the lines of action items, things that we can actually do. You mentioned black carbon and the role that black carbon plays in global warming. According to a recent NASA study, I assume it was a NASA study, not a George Soros study. It could have been by Dr. Hansen. Black carbon, which is really just particulate matter or soot, I think you used the word soot actually, from industrial and biomass sources, is having a significant warming impact in the Arctic because it reduces the reflectivity of snow and ice. And according to NASA, about a third of the black carbon in the Arctic was actually coming from South Asia, and a third from burning biomass or vegetation around the world, and one-third from North America, Russia, and Europe. What can be done to reduce those sources, and is it happening? Is anyone doing it?
The origin of black carbon that's deposited in the Arctic is a very important area for further research, but it's clear that the U.S. has a leadership role to play in this regard. There's many, many things that can be done. For example, we can replace diesel generators in the Arctic with alternative energy sources, and where that's not possible, improve the efficiency and particulate controls on these generators. We can replace coal or biomass burning in residential stoves with alternative fuels, or improve the efficiency in particulate traps. Stringently regulating diesel use in cars and trucks is very, very important, and options include upgrading the vehicles, installing end-of-pipe filters, better vehicle maintenance, and buyback programs for super emitters. We also need to not approve new coal-fired power plants, phase out of existing coal-fired plants by increasing energy efficiency and the use of alternative energy, and where coal-fired power plants must continue to operate for now, implement more effective particulate controls. If we did all these things, we could start seeing progress by January 2009.
Thank you, Ms. Siegel. Rohrbacher.
Thank you very much. Just surprised that my staff had not submitted quotes before, but we will be submitting these quotes for the record. Just one I happen to have with me right now is from Dr. William Gray, who is one of the world's most respected hurricane experts and emeritus professor of atmospheric science at Colorado State University, who suggests so many people have a vested interest in this global warming thing, all these big labs and research. The idea is to frighten the public to get money to study it more. That's the end of that quote, and there's about dozens of other quotes that we will put at least 5 or 6 of them in the record. Dr. Gray is a respected person. There's many, many respected scientists who are skeptical, not of the idea that the Earth is going through a warming trend, but that this has something to do with human activity. Show that I just happened to see in the History Channel, which we repeated, and it's a wonderful documentary. Went into great detail about the sun and about volcanic activity and those things that caused the temperature to change then. Let me ask you this. 1,000 years ago, before this mini ice age, before this trend that brought the temperatures down, which I might add, all of the studies that I've seen on global warming start at the bottom of the mini ice age after 500 years of reduction of temperature, using that as the baseline and you're a degree and a half warmer than it was at the lowest point, as if we should be concerned about that. Let's go back to that 1,000 years from before. How many polar bears were there 1,000 years ago when the temperature was much different than it is today?
Well, I don't think we know the number of polar bears at that time. We do know that polar bears existed back then.
So, is it better if we say they can't exist if it's going to be warmer now? We could assume there are fewer polar bears. Now, is the number of polar bears 1,000 years ago what would be the natural polar bear population, or is it what it is now?
I don't believe there is a natural number of polar bears. There will be the number of polar bears that their habitat can support. And
no, I think it's wonderful to see these pictures of the skinny polar bear up there and tearing at our hearts, that those of us who love animals, and I do, and to just, then we have to do something, which then gives us the right to have the acceptance of our people to regulate their lives in the name of saving that polar bear who now is so thin, as if we are causing the polar bear to be thin. But in reality, 1,000 years ago, before any human activity had anything to do with temperatures on the planet, even if you accept that 1,000 years ago, the polar bear population was totally different. It was warmer. Maybe you could tell me, what was the ice cap like, or what was the level of ice in Greenland 1,000 years ago?
Our observations are not as good as we'd like, and we're working on that. The Climate Change Science Program is going to do a report on that, and I am one of the authors. And so, be very clear, I cannot either prejudge or presage what that report will say. What we can say is that Greenland seems to have responded to temperature. When it was warmer, it got smaller. When it was colder, it got bigger. And that we are now pushing towards temperatures that will pass those of the medieval warm, that will pass those of the mid-Holocene.
That's
business as usual.
No, we are a degree and a half warmer now than it was 150 years ago, and we have so much less volcanic activity, etc. Just degree, and it was how many degrees warmer was it 1,000 years ago?
There are places that we do not have
Greenland and Iceland.
We do not have a reliable global, probably a degree or two, something in those neighborhoods.
What do the ice cores show?
The ice cores show a very small signal that's about a degree and a half, something in that neighborhood in the summit of Greenland, which is the one I work on, and that's based on my work.
How much was it? How much warmer was it when we had all of these Vikings and everybody living in Greenland and Iceland, and they have all this agriculture going on? How much warmer was it then? Was it 8 to 10? I think the History Channel put it at 8 degrees to 10 degrees warmer.
That would seem very large to me. The ice core records would indicate that we're back up to where we were, if not passing it.
Yeah, that's probably the case. I, by the way, did a story, was interviewed by a reporter from the Wall Street Journal, and there's now a potato farmer in Greenland. So we're back to about where we were 1,000 years ago. So my suggestion, if you want to find that warmer period to use, I'd suggest the Holocene thermal maximum, the warmest it got since the end of the last ice age, and that would be in the range of 6,000 to 8,000 years ago. It was warmer than it is now. It's been cooling since.
Right. So 8,000 years ago, there was a period with almost no ice up there. And we think that today...
Yeah, and the tree line was further north. You can find the frozen remains of the trees almost to the shore of the Arctic Ocean around the entire West.
So it was dramatically warmer 1,000 years ago and 8,000 years ago.
No, incorrect. We were probably warmer now than 1,000 years ago. We probably exceeded that.
But we do have, we're actually, well, we're all past time. We do have those coming up. We do need to conclude the hearing. I just have one more question for Dr. Alley. You said that the permafrost and frozen heat, the possibility of release of carbon, methane in the permafrost and frozen peat was a big hole in the modeling by the IPCC of how the globe, how our climate could change, how our climate could warm. But you didn't say how much. Do you have a sense of how big of the effect of that can be?
What it looks like based on simple models, based on what we know, is that it doesn't, if we humans burn all of our fossil fuel, the feedbacks from the permafrost do not double what we did, but they're large enough that they would matter to what we would do.
Large enough to matter.
Yeah, so order, we scientists like to say order up when we're a little bit confused, so order of 10 to 30% sort of feedbacks coming out of this, amplifying what we would do in a burn it all, if you would like to say.
If you could take all of the readily decomposable carbon, because some of it is kind of locked away in the form, it's just not going to come out. But, I mean, so that's killing everything and burning up everything. It would double the it's equal to the atmospheric reservoir, so it would double atmospheric CO2. So we're not going to do that, even under the worst scenarios. But it does look like a significant percentage, a non-ignorable percentage of it could and probably has started to be mobilized.
Anyone else? Okay. Well, with almost 3.5 minutes left in my time, I will now recognize Warbacher is not here. Well, in that case, I think that our hearing is at a close. I want to thank all of you for testifying today. There may be additional questions that can be submitted in writing. You may think more about the scientist you know named Steve and provide additional answers. And with that, the witnesses are excused and the hearing is now adjourned.